Okay, students, so we've been learning about different types of maps, and today we are going to learn about topography maps, or topographic maps, which also is the topic of topography. So, topographic maps, and what that is, I have an example here, is a map that shows the physical features of land, such as the mountains, rivers, and lakes, and elevation changes. So I have some vocabulary lists for you guys. And what these maps show is where the land raises and falls. And for today, we're just going to look at where it raises. So if we see a hill, when we're looking at a flat map, these lines help us see that it elevates in that area, so you can see the shape of the hill. So does anybody want to read the definition of elevation?
I'll do it. Okay. Elevation, it's a raised place such as a hill.
So what do you think these are pictures of here?
I think, hills or mountains?
Yes.
Some of them are big and some of them are small.
Yes, exactly. So depending on the size of them, they could be considered hills or mountains, but it's just the elevation of the land. So does somebody want to read the definition of topography?
Me.
Go for it.
Describes the physical features of an area of land. Typically includes natural formations such as mountains, rivers, lakes, valleys, and elevation changes.
Perfect. So we are just going to talk about elevation today, but these lines, depending on if it goes up or down, it could actually be a valley or a lake, but today it's just going to be mountains. That's what we're going to be worrying about. So the next vocab word you see there is contour lines, and that's these lines here. So to give an example, if we had something that looked like this, what do you think that might look like over here? Would it look like this?
No.
No. Would it look like this?
Yeah.
Yes. And another note for these lines is the closer they are together, the steeper it is. So if we have something that looks like this with lots of very, very, very tight lines, and then all of a sudden some very wide contour lines, that would be maybe a hill that goes like this and then has a very high peak.
Oh, so the middle is the top of the mountain or the hill?
Yes. Sorry. And so, does someone want to read the definition for a concentric?
I will do it. Concentric, having a common center, concentric rings.
Perfect. So that means that this center, all of these have the same center. That's the highest point. And then that's why all the lines are connected. And every single line is at the same level. So let's say this is a huge mountain. This might be at sea level. This might be 1 mile high. This might be 2 mile high. This might be 2.5 miles high. We're not going to worry about numbers today, but it just means that it's elevating upwards, and if it's connected here, then that's the same level of elevation going up.
So the ring the entire way around is the same elevation at that point?
Yes, so if this is a mile above sea level, then this whole part is a mile above sea level. It's like this.
I got it.
This is kind of a 3D way to look at it.
Ah, I see it now.
So, what we're going to do first is I have a little exercise. So if you guys can look at, you have the example on the left is a topographic map, and the blank spaces on the right, I want you to use your crayons and draw what you think this would look like if you color it there. And you can use your crayons.
Can we work together?
Yes.
I love this one. So this one kind of looks like the one she had on the board. So I'm going to just draw it like the one on the board.
Me too.
So I guess they'd be connected at the bottom, like so.
Since you see these lines are together, then you know they have.
Oh, so it's not two separate mountains. It's going to be one mountain together.
Depending on, where you're, where the low.
What the heck is the first?
Okay, just go there. And you can color in. Oh, awesome! You can add just like I did with like the 3D. That's a good job with that.
I don't understand the third one.
Me either.
Okay, so with this third one, we can see this bottom part is very similar to this top one, right? So we know that's going to look similar.
Oh, so it's going to have a mountain like that.
It's gonna be the
and
one
two
mountain.
peaks.
Mm-hmm. And then we have one behind it that is separate, so you can see it's not connected to those other mountains.
Gotcha. Okay. And the rings are closer together, so this one's probably going to be a bigger mountain.
Yes.
I'm gonna draw this differently.
I'm gonna drop my finger. Cool.
All right, very good. So you guys feel comfortable with that?
Yes.
Okay.
Yeah, that last one was tricky, but I think it did it.
All right, so let's review for the first one. And I have a volunteer come up and draw on the board what your mountain looked like. You don't have to draw the topographic one, just what your mountain shape looked like.
For number one,
Yes.
I'll do it. On number one, I noticed it looked like the one you did on the board, so I knew it had to look something like that. So I drew mine to look like that because the rings went like this around it. Is that
Perfect.
right?
Yes. Does everybody agree? Does everybody have the same thing?
yeah.
All right. And so for number two, does anybody want to volunteer to do number two?
I will. This one was kind of confusing. So I think because it had the two circles, it would just be like this. But it's one mountain all around on the bottom.
Yes. And what confused you about
So I
it?
guess I go like this.
So if this is sea level, you're correct, yes.
Okay.
Is there anything else confusing about it, or?
No.
How would you know how steep it is? Do we see maps like this? Like, how do you know if it's really steep? Would it have numbers on it?
Yes, as I said in the beginning, there are maps with numbers attached, so you can see the space in between, how far apart it is, or how close together it is. So it might be like by miles, things like that. But today we're not going to worry about it. We're just worrying about shapes. But so, since you brought it up, if we could do a quick example. If you see one that has, we're just going to do a regular. Let's say it's by miles because it's a huge mountain. We might go like this, and if this is the base, this might be 1 mile up, 2 miles, 2.5, 3, 3.5. So you can see that it's going to go like 1 mile, 2 miles, and then it's going to get a bit steeper, like that.
I get it.
Alright, so next, did we do number 3? Does somebody want to volunteer for number 3?
That one was kind of hard.
Yeah, we
But-
didn't get it.
Does somebody want to give it the best shot, or do you want me to do it? You.
Yeah, can you show
Okay.
us how to do it? Because we weren't sure.
Yes, perfect. So as you can see with the topographic map on the left, you can see 2 hills that are connected at the base. So even though they're separate, they have a similar base. And it looks very similar to number 2 up top. So number 2 up top looked like this. Something along those lines.
Mm-hmm.
And then we have a third one in the back. So if we're looking from an aerial view down, we can see that's a third mountain in the back that's not connected to the other ones at the base, but it is pretty steep. So if we were looking at it straight on, we would know there's a pretty steep mountain right behind it.
I keep forgetting we're looking down on it.
Yes, it can be tricky. So you're looking from the sky when you look at the topographic map, and then in the 2D, it's as if you're standing on the street just staring at the hills.
Okay, that makes sense now. Get it.
All right. So next, does anybody have any questions?
Okay.
So next, I'm going to give you this worksheet, and what I want you to do first is I want you to draw just on the top part a topographic map. Use your imagination. You can make it as complicated or as simple, whatever you want, but take your time.
Any kind you want? Just
Yes.
drawing.
And you use different colors.
I'm gonna hide mine.
You'll have 4 minutes, so take your time. And let me know if you need help.
If we're doing more than one mountain or a hill, can I do a different color?
Yes.
Even if they're gonna be kind of connected? Is
Yeah.
that okay?
Of course. As long as you can read the map, you can use all the colors you want. Feel free to decorate it if you want to.
After I do my topographic, I'm supposed to draw in 2D?
You don't have to.
Oh, 3D.
Yeah, you don't have to do that. You should just be creative. That's what
Yes.
we do Play-Doh. But that might actually be a good exercise if you want to do that, and that way that'll help you see it better when you do the 3D. We're using one of these examples.
I was just looking, I couldn't remember. So the closer the rings are together, the more steep it is,
Yeah.
right? Really steep one like that. Flat one to the side. There.
Good job with color coding. Okay, so who wanted red?
Me, you read.
All right. So now we have Play-Doh. In the spot where you guys doodled your little 2D, now I want you to make a 3D model. And you'll have 5 minutes, so take your time. Some tips and tricks might be to do one layer at a time. If you could do that, that will help us see it better. So I'll do a little example with you just in case you need an example. We could start with like, here's one of the concentric lines.
Why would you need to know a topographic map?
We need to know topographic maps because when we're looking at a map, we can't see the shape of the land. So if we want to travel through somewhere, it's very beneficial to know if there's a high mountain there, if there's a low valley. So those are maps, most maps we use just to get from point A to point B, but if there are rivers and valleys and mountains, that helps us see the shape of the land.
How would you draw a valley?
It would be the same as these lines we are using, but it would be, instead of an elevation, it would go different. So you could do the same thing, like, say, here is a place, and this is where the land, this is sea level, and it goes like that. So it's like the opposite of a mountain or a hill. It's going down, and that's where numbers come in useful when we use numbers. Today we're just looking at the shapes, but numbers would say, hey, this is 1 mile down, or this is sea level, this is 1 mile down, this is 2 miles down, like that. Wow, okay.
I don't know how you can be below the sea.
I don't remember. Would you be in the water?
Not when you're on land.
If it's below the sea, then you'd be underwater. Seems crazy.
Where's the globe?
Where's the globe?
There we go. So, here's the sea. When we go on land, there is a land barrier. So if we are in here, let's say the land could dip down, and you're not going to be in water because there's a land barrier.
Mm-hmm. Oh, okay.
It's like a bowl.
Yeah.
Yes.
So I think I'm good on my 3D model map now.
Okay, put it on your paper. Perfect.
Because it's covering up my drawing.
Okay.
Wait, those ones. Is this one touching if the line isn't connected?
Well, if it's not connected at all, then we would assume that it's at ground level. Yeah, so it would, exactly, so it would just touch right at the base.
Okay.
I think I did mine.
It looks really good.
This one's like, it's got little points.
Like the
It's
Grand
like that.
Canyon.
I did the Grand Canyon.
Awesome job, you guys. Well, that's it. So good job. And we'll turn those in and we'll take a look. You guys can share it with each other if you want, but very good.
What was your inspiration?
I have no idea.
Not the Grand Canyon?
Oops.
Oh, it's still filming, right?
It should be.